Good morning,
Morning.
Prophet.
Good morning, everybody. Good morning. Morning, everyone. Good morning. All right, so it is 8 o'clock. Good morning again, and welcome, everybody. Let's continue. We're going to continue with 5.5, solve polynomial inequality. Yes, go ahead. Any comments? All right, so 5.5, solve polynomial inequalities, objectives, solve polynomial inequalities, and solve rational inequalities. Well, did you guys remember in one of the sections before we solve inequalities for quadratic inequalities? And we mentioned that the solution was either above the x-axis or below the x-axis, and the answers were written as intervals. Probably you guys, some of you remember. And it is the same idea here. Yeah, most likely you guys remember. And the same idea here. Welcome, Connor. Um, and exactly same idea. You know, when this is the polynomial that is given. Let me bring this down and let me use here. This is the polynomial that is given. It might be greater than 0, less than 0, greater than or equal to 0, right? So again, if f of x is greater than 0, then the solution is gonna go, it's gonna be above the x-axis. If this is less than 0, less than or greater, less than 0, less than or equal to 0, the solution is gonna be below the x-axis. So let's give it a try. Let's remember what we did. For example, they said solve each inequality. Also remember that, let's start with it. Remember that you have your handout from the basic functions that you should have. Notice, let's start with a x cubed minus 4x squared greater than 0. If you notice here, we have the leading term is an x cubed. That's a cubic function, right? So with this, you get an idea of visualize how it looks, the end behavior, at least, all right? Okay, so we're gonna do the same steps as we did before. Steps, first, 1, we're gonna equate to 0. And we're gonna solve for x. All right, let's do that. Notice, as I said, I have x cubed minus 4x squared equals to 0. How can we factor the left side, right? Well, we can factor out the x squared, correct? If we factor out the x squared, notice we're left with x minus 4, correct? So from there, we can solve for x. So here, x squared equals to 0, which this is a repeated, by the way, this is a repeated 0 here. And this is x equals to 0. And x minus 4 equals to 0. So we solve for x, x equals to 4. So by the way, if we wanted to graph this this function right here, or this equation right here, notice this is, remember multiplicity even. Here at 0, the graph does not cross the x-axis. It only touches the x-axis and goes back. Here, the multiplicity is odd. It means that it's gonna cross the x-axis at x equals to 4. Just to remember what we covered before, all right? Okay, now that we have x0 and x4, remember that we...
Wait, so even touches and then
yes,
odd crosses?
correct, you're right, yeah. Even multiplicity touches only the x-axis and go back, and odd multiplicity crosses the x-axis, all right? If we were wanted to graph this equation, that's what we consider. Alrighty, and remember what we did before. We found the x values, and then we created a number line here, right? And we use these two values, x0 and x4, which are right here, 0 and 4. And remember the steps. We choose test points. Easy test points for you to plug in. Let's say -5 here. Notice we also divided the number line into 3 intervals, from -infinity to 0, from 0 to 4, and from 4 to infinity. Again, we choose the test point. Easy test points, you guys, to plug in. I chose -5, 2, and 5. And then I write the factors again. Notice x squared comes from x squared here. X minus 4 comes from x minus 4 right here. And remember, all we want here, we're going to do it together here, okay? We want to plug in this value here, and we want to see what is the sign that we get here. Okay, let's do it together. If we plug in -5 into x squared, what would be the sign here, you guys?
Positive.
Positive.
That would be positive. Thank you, Sherry. That would be positive, right? If we plug in -5 in x minus 4, what would be the sign here? That would be negative.
Negative.
Perfect. So now we're gonna multiply both of them, right? Positive times a negative is a negative, right? Let me use a different color here. That's the sign that I'm looking for. So let's do the same.
Going to have this on our test.
Are we gonna have these kind of problems on the test? Cherry, that's your question?
Yeah.
We might. They're not difficult, by the way, okay?
And when is the test?
We'll talk about that a little bit later, Cherry, okay? We'll talk about that. Okay, let's plug in the 2. Okay, if we plug in the 2 into x squared, what will be the sign here?
Positive.
Positive, right? All right, everybody. Why did we plug it in x minus 4?
Negative.
And negative.
Negative, right? Okay. Positive times a negative is also negative here. Perfect. Let's plug in the 5 really quick. 5 square is positive 25, which is a positive, right? If I plug in the 5 here, is 5 minus 4 is a positive, right? And positive times a positive is a positive. Now that we have the signs here, let's go back to the inequality. Notice, let's go back to the inequality. The inequality is greater than 0, right? That means that the solution is gonna be above the x-axis. So that means that the solution, since it's gonna be above the x-axis, the solution is gonna be the interval where you have the positive signs. This
So
positive
it's
sign
going
right here, right?
for infinity.
You're right. The solution is gonna go from 4 to infinity. That would be the solution, you guys. Solution.
Because all of it has positives, right? Because
You're
like
right.
x squared is
Yes.
positive, x
Yeah.
minus 4 is positive. Okay.
Correct. And because also the original inequality is greater than 0. That tells us what is the sign to look for. All right.
I'm not understanding.
Yeah. Since this is greater than 0, right? That means that the solution is gonna be above the x-axis, and we're looking for solutions that are gonna be positive. Okay. So when we do the sign analysis here, and notice we get negative, negative, and positive. This would be the solution. Why is that? Because that's greater than 0. We're looking for solutions to be positive. That's the reason. Okay. If this has to
Can
be,
you watch some fucking shower?
let me focus here. If we had less than 0, you guys here, if this had been less than 0 instead of greater than 0.
You know my carpet a tiny bit.
All right. Somebody's
It's
talking
right behind
there.
the door.
All right. Somebody's talking there, and everybody we're listening while
But
you're.
he's outside in the backyard now.
All right. Somebody's talking besides the lecture. I don't know who is that. We can listen to anything. Okay. Just to let you know. All right. Again, if this had been less than 0 or less than or equal than 0, you guys, the solution would be these two intervals where we have the negative signs. Is that clear? But
So it would be negative infinity to 0, and then 0 and 4, 0 to 4.
yes, that would be those two would be the solutions if it had been less than 0. But since this is greater than 0, let me write the solution. Since this is greater than 0, the solution is going to be from 4 to infinity. That would be the solution. Ready? All right. So I'm going to let you try B really quick, okay? All right. So let me let you try B really quick. So again, let's follow the same steps as we did for A. Let's factor the left side first. All right, notice that you can factor out what? You can factor out the x, by the way, right? All right, so first thing that I'm gonna do is I'm gonna equate it to 0. And then I'm gonna factor the x, right? And I'm left with x squared minus 4x minus 12, and that would be equals to 0.
So would I factor it again after that?
Yes, let's try to factor the trinomial. Let's see if we can factor x squared minus 4x minus 12. Let's use big X. Let's see if that works, okay? Negative.
Wouldn't it be negative 6 and positive 2?
Yes, that works. -6, and +2. Very good, you guys. All right, so let's write it down. That will be x times x plus 2 times x minus 6 equals to 0, right?
So
Now
there's three. So there's three values.
there are three values, you're right. So let's solve for x. So that's x equals to 0, or x equals to -2, or x equals to 6, right? So we got three values here. Those three values. So those are the three values that now we're gonna do the number line, and we're gonna use those three values, okay, on the number line.
So it'd be
All right.
-infinity to 0.
Yes, so yes, pretty good. So I'm gonna do it right here, okay? So I got, let's say here I got 0, -2, and +6. So I got 1, 2, 3, 4 intervals now, you guys. I got from -infinity to -2. I got from -2 to 0, from 0 to 6, and from 6 to infinity. All right? Everybody okay so far? All right. So now let's choose test points. Let's choose test points now. That will be the next step. Test points. Test points. Choose easy test points right here. Well, let me choose -5 again here. I'm gonna choose -1 here. I'm gonna choose here +1 here, and I'm gonna choose 10 here. You can choose your own, okay? Easy ones to plug in. Okay. Next, I'm gonna write. It's gonna be three factors here. It's gonna be x, x plus 2, and x minus 6. Okay, so that would be x plus 2, and x minus 6. And at the end, we're gonna multiply all of them. X times x plus 2 times x minus 6. Already?
Can you move the paper down?
Sure, definitely.
Or move it up. Move it up, sorry.
No problem, I'm there. All righty, let's do the same as we did before. Let's plug in those values and let's see what are the signs that we're getting, okay? So let's start by plugging in the -5. If we plug in -5 into x,
It's just negative.
perfect. What about in x plus 2?
Negative.
Negative again.
Negative, right? So that would be a negative. What about in x minus 6?
Negative.
Negative, right? Okay, now let's multiply the signs. Negative times a negative is positive, right? Positive times a negative?
It's
Negative.
negative.
Negative, right? I have a negative right there. All right. So now let's plug in the -1. The -1 in the x is negative. The -1 in the x plus 2 is what? Positive, right? The -1 into x minus 6 is negative. Negative times a positive is negative. Negative times a negative?
Positive.
Positive, right? Perfect. So let's do the same with 1 and 10. Let's see what the signs we get. All right. 1 in the x is positive. For x plus 2 is also positive. For x minus 6 is negative. And if I multiply positive times a positive is positive, positive times a negative is negative.
Negative.
Perfect, thank you. So now let's continue with the number 10. 10, if I plug it in into x, that would be a positive. For x plus 2, also that would be a positive. for x minus 6 also is going to be a positive, so we get a positive. All right, now that you got your signs in the bottom row, go back to your inequality and see what is the sign that you're looking for. Notice it's greater than 0. That means that we want also, again, the answer to be positive. Is that clear?
So it would be 10.
Yes, so let's go back and see what would be the signs that are positive, and let's choose those intervals which are going to be the solutions, right? So let's write the solution. It's going to be from negative 2 to 0, right? Negative 2 to 0, comma, and 6 to infinity, right?
Wait, why is it negative 2 to 0?
Because
It's not all positive.
remember, Nadia, that we care about the bottom row. That's where the solution is going to be. This bottom row, the signs tell us the solution.
Oh, so it's not all
It's the bottom row that let us know what the solution is.
so it's the bottom row, it's not
The
the
bottom
last
row.
row.
I mean,
Russ, we have the other rows to figure out the bottom rows.
you're right.
If
Yes,
you don't have
Cherry.
the other rows, you can't figure it out.
Exactly. You're right. So by using the other
Because
rows, go ahead, Cherry.
it's Nadia. I saw 10 and I thought that since it's all positive, it's only 10. Like, so 6 to positive infinity.
No, remember, we're using, these are test points for us just to check the signs. And when we get the bottom row right here, that's where that's how we choose the intervals that are going to be the solution, depending on this inequality symbol, right, Sherry?
Yeah.
All right.
Professor Rivera, I have a
Yes.
question for you. So if it was less than 0,
Yes.
then it would be negative infinity to negative 2 and 0,6, right?
You're right. That
if it
would
was
be,
less.
yes, definitely. You are correct. So
So you only go off the last row.
Roz, it says, then why do we do the other rows? Well, we need the other rows to find out what will be the solutions. That's the reason. We need these rows because of these rows, we get the solution. Another way to do it, you guys, you can plug in these values directly to this inequality right here. And if you can do it in one single step, then you're gonna get these signs right here. Okay, so that would be the other way. Alrighty, so let's continue. Now we're gonna do a rational inequality. We're gonna solve this rational inequality, x plus 1 divided by x minus 1 greater than 0. The idea is similar to what we did before, but notice that now we have a numerator and denominator, right? So I have the steps here, okay? Step number 1, equate to 0. Let's make f of x equals to 0 and solve for x. All right, let's do it together here. So first thing that I'm gonna do is I'm gonna write x plus 1 divided by x minus 1 greater than 0. And we're gonna solve for x. All right, so in order to solve for x here, you guys, one way is to get rid of the fraction, the denominator. How do we get rid of the denominator? By
multiply both sides by x minus 1.
You're right, by multiplying both sides by the least common denominator, which is x minus 1. Okay. If you multiply both sides by x minus 1, notice what happens here. I'm going to do it right here. X minus 1 times x plus 1 divided by x minus 1 equals to 0 times x minus 1. And when that happens, on the left side, the x minus 1 with the x minus 1 divides out, which is equals to 1. And you're left with x plus 1. 0 times a number is always 0. So you're left with x plus 1 equals to 0.
So just be x equals -1.
You're right. And if we solve for x here, x is equals to -1. X is equals to -1. All right? So the shortcut, you guys, every time that you have a rational equation and you're going to solve for x and you equate it to 0, you're going to be left with the numerator equals to 0 and you solve the numerator for x. That's the shortcut, you guys, all the time. All right? So we got x equals to -1. And now step number 2, it says find values which function f is undefined. Find values which function f is undefined. Well, what are the values that would make it undefined? Well, we need to check the denominator. Make the denominator equals to 0 and solve for x. I'm gonna write it. Make denominator equals to 0 and solve. All right, so that would be x minus 1 equals to 0 and x equals to what? 1, right?
1.
Yes. All right. Now notice we found two values, x equals to -1 and x equals to 1. Now we're going to use those two values and we're going to do the number line as we did before, you guys. Okay. So that would be a step number 3 right here. Let me focus here. All right. Okay. Let me do it. Right there. It says use number found in 1 and 2 to divide the real number line into intervals and choose test points to evaluate it. So we're going to do the same as we did before. I'm going to give you a minute for you to try it, please, and see what would be the solution that you guys find. All right. Okay. So again, create the number line.
So when you create the number line, you take, so for this one, you would like take -1 and you pick a number on to the left of it. So it'd be -2.
Yeah, right? You pick, yeah, let me just go back a little bit. You pick both numbers, -1 and 1.
Yeah.
Okay. And you pick numbers as we did before. Let's say that this is -1 and 1. And then do exactly the same as you guys did before. Let me give you a minute for you to give it a try. Divide the intervals, create the intervals, and then choose your test points, plug in those values. Now, plug in those values. You can plug in the value in the x plus 1, x minus 1, and x plus 1, x minus 1. For example, here are the tests.
Can I do like a -2 and then a +2 or no?
Yeah, you can do that. Yeah, definitely. Yeah. Yeah, you can do -2 here. All right.
So for the last number, you would pick to the right of, like a number would be you would pick to the right of, and for all the other numbers before that, you would pick a number to the left of. Yes,
you're right. So let me -infinity to -1, -1 to 1, and 1 to infinity. So easy test points, you know, I like the -2 here. That would be okay. Here I would pick 0. 0 is an easy number to plug in. And here I could plug in 2 or 5, any number, easy numbers for you to plug in. Okay. And here I can plug in, I can write x plus 1. Here, x minus 1. And the last one, I can write the x plus 1 divided by x minus 1. All right. All right, let me give you one more minute for you to finish, and you guys can tell me what the solution is here.
I think the solution is negative infinity, comma, -1. That's 1. I have one is 1 to infinity.
Okay, all right. So let me wait for another students to see if they're getting the same as you getting, Cherry. Thank you. All right. So let me catch up with you guys. If we plug in the -2 in x plus 1, I'm gonna get a negative, right? If I plug in the -2 in x minus 2, I'm also gonna get a negative. What is negative divided by negative is what? Positive, right? If I plug in the 0 in x plus 1, that would be a positive. If I plug in the 0 in x minus 1, that would be a negative. Positive divided by negative is a negative. If I plug in the 2 in x plus 1 is a positive. If I plug in the 2 in x minus 1 is a positive. Positive divided by a positive is a positive. All right. Now that you guys found your signs, go back to the inequality and check the sign again. Since this is greater than 0, we're looking for positive numbers, right? Right there. You know what? Let me, oops. Right there. All right. So we're going to choose the intervals. We're going to choose the intervals where we got the positive values. Let me see here.
Based off the last row.
Yes, you're right. So solution, let me write the solution here. Solution is going to be from -infinity to -1 and 1 to infinity. That would be the solution, right? All right. Okay, I'm going to leave that next exercise for you to do it later, okay? So, yes.
I have a question, Professor.
Yes.
Do you put like a comma or
here, I'm using a comma here.
solution?
Yeah, a comma.
We don't need to put union.
No.
Okay.
And then for problem B, it would be bracket, right? Because it's equal to.
You know what? Let me go back to here. The question was, do we have to write a union here? My math lab is a little bit picky, you guys. I'm gonna go back to my math lab, okay? And I'm gonna think how my math lab is gonna like the solution here.
My math lab is
Yeah,
hard sometimes.
you know what? It's kind of weird. Those guys are weird, you know. And you know, thinking about also that another way to write the solution as I can also use the U as the union. It was J, right? J. It was you. I'm not sure. But I can also, yes. You know what? I can also write it as a union. You know, and probably my math lab would like the solution to be that way. Ready? Okay. So any questions you guys so far for inequalities? Seems pretty basic,
So
right?
For B, like since it's less than or equal to, it would be a bracket.
Yes, you're right. For B, it would be a bracket. Yes, you're right.
Okay.
Very good
All right,
observation.
thanks.
Thank you, Nadia. Alrighty, so I think that we're done with 5.5. Let's continue with 5.6. 5.6. Let me close my window right here a little bit. All right, much better. All right, notice 5.6. The title is the real zeros of a polynomial function. The real zeros of a polynomial function. All right. So let's read the objectives. Objectives. Use the rational zero theorem to list the potential rational zeros of a polynomial function. Find the real zeros of a polynomial function, and then solve polynomial inequalities. All right, so let me tell you what we're gonna be doing here in 5.6, right? So everybody in this class knows how to factor trinomials, right? We know how to use the big X, correct? All right, so no problem with that. Now, what we're gonna do in this section now is we're gonna be factoring polynomials with a degree greater than 2. Might be degree 4, degree 5. So that's what we're gonna be learning in 5.6 and 5.7. So I wrote some theorems here that we're gonna be using, and let's read them together. It says the factor theorem. It says suppose f is a polynomial function, then x minus c is a factor of f of x if and only if f of c equals to 0. All right, so we're gonna do an exercise to understand this theorem here. It says, example, use the factor theorem to determine whether, it should be whether, let me write it there, whether the function f of x 2x cubed minus x squared plus 2x minus 3 has the factor x minus 1. All right. There are two ways to check if f of z is equals to 0. Here, c, notice, let's go back here, x minus c, right? Which is similar to x minus 1. What is the value of c? The value of c here should be 1. So to check if x minus 1 is a factor of f of x, there is more than one way. And one of the way is, do you guys remember synthetic division, you guys?
No.
No.
All right, I think that you do it, and we're gonna do it together right here, okay? Synthetic division. All right, so let's do it together.
So one way to find it is synthetic division?
That's one way. The other way is long division. Remember the long division that we practiced last time?
That one
Yeah.
sucks.
All right, so synthetic division is easier, by the way. You're gonna like synthetic division, but in order to use synthetic division, the factor has to look like x minus c. So when we use synthetic division, we get the coefficients of the function. So we're gonna write down the 2. We're gonna write down the -1, which comes from x squared. We're gonna write the 2, and we're gonna write the -3. Is that clear how we got those numbers? Those numbers are the coefficients of f of x, by the way.
Mm-hmm.
All right? And then notice we have x minus 1. Well, if you notice, c is equals to 1, right? This 1 goes right here.
Wouldn't it be -1?
No, that's a good question, because notice here is x minus c, right?
Hmm.
The value that goes here is c. C is 1, not -1. This negative is the same as this negative right here. Is that clear? So
Kind
C
of.
is 1. C
Okay.
is 1 right here. Ready? So let's now continue here. This is how synthetic division goes, you guys. First thing that you do is you bring down the 2. The first number that you have here, bring it down. Right there. Okay? And then this is what you guys do next. You multiply 1 times 2, which is what? 1 times 2 is 2, right? And you write it here. And then you add these two numbers, -1 plus 2 is positive 1, right?
Mm-hmm.
Yes, and then you keep doing the same. 1 times 1 is what? 1, right? You write it here, and you add these two numbers. 2 plus 1 is what? 3, right?
3.
And then you do the same. What is 1 plus 1 times 3? 3. What is negative 3 plus 3?
0.
0. All right, notice. If you get a 0 here, that means that x minus 1 is a factor of f of x. Okay? That means that if we were to factor f of x, this x minus 1 is a factor of f of x. Let me check some chats here. Yes, Roger, you're right. Yes. And I'm gonna do, it says, if it were x plus 1 instead of x minus 1, would we put the negative 1? Yes, you're right, Roger. And I'm gonna do another exercise, okay? I'm gonna do one exercise to clarify. Good question from Roger here, okay? All right.
I thought it was just we put the number and not the symbol.
All right, so let's try another one. Let's finish this problem. So this is the remainder, by the way. This is the remainder. If we were using long division here, you guys, this will be the remainder at the end. If this number is 0, that means that x minus 1 is a factor of f of x. Okay? So I'm gonna write it yes here. Alrighty? All right, so let's try another one. Let me write here b, okay? And let's say that I wanna see if x plus 2 is a factor of f of x. Is that clear?
Wait,
Terry, question, yes.
Yeah, I have a question. Can you explain the last step that you were doing, because I'm kind of confused on like what the yes is.
The yes means that x minus 1 is a factor of f of x.
Oh, and why is it yes?
Because the remainder is 0.
Oh, we
That's
only
why.
care about the last one.
Yes, this number. If this number is 0, that means that x minus 1 is a factor of f of x. Okay? We're going to be using, we're going to be talking about more next section also. We're going to do a lot of synthetic division, okay? We're going to be factoring using synthetic division, by the way. Now, let's try x plus 2. All right, so let's do similar steps as before. We're going to write the 2 here, negative 1, 2, and negative 3, right? Now, the good question is, which number goes outside now?
-2.
That would be negative 2, you're right. Now, let's see why. Notice here is x plus 2, right? But remember, it has to look like x minus c. So I can use this trick here, you guys. I can use this trick. Notice x plus 2 is the same as x minus negative 2, right? Are those two the same? Yes.
So ultimately, you would just flip the signs.
Well, it depends. Here, when you say flip the signs, let's not get confused here, okay? So basically, if I rewrite it here, I know that now C, because this sign now corresponds to this sign, now C corresponds to negative 2. So the negative 2 now goes here. Is that clear, you guys?
Mm-hmm.
And then we're ready to do what we did before. And I'm gonna let you finish this problem. Bring down the 2 and now start multiplying and see if x plus 2 is a factor of f of x.
No.
All right, so let's give it a try. Some of you said no. Negative 2 times 2 is -4. -1 plus -4
-5.
is -5. -2.
-10. I mean 10.
Yes, -2 times -5 is positive 10. 2 plus 10 is
12.
12. -2 times 12 is -24. And remember, you end up with -27. So if this is not a 0, then that means that x plus 2 is not a factor of f of x, right? So I'm going to write here no. Alrighty? So alrighty? No problem. No problem, Cherry. Thank you. All right. So we got this, guys. Seems that we got it, right? All right.
Yeah.
Let's move on. So we're going to be doing a lot of synthetic division in this section and next section, by the way. All right. Now let's read this theorem. It says number of real zeros. It says a polynomial function cannot have more real zeros than its degree. All right. Remember, what is the degree of a polynomial function? The degree of the leading term. Okay. All right. So let's continue. Let's read this theorem here. Rational zeros theorem. It says, let f be a polynomial function of degree 1 or more or higher of the form f of x equals to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub 1 x plus a sub 0, right? It says where the coefficient is an integer. It should say where the coefficient is an integer, by the way. It says if p divided by q in lowest terms is a rational zero of f, then p must be a factor of a sub 0. A sub 0, remember, a sub 0 is a constant, you guys. A sub 0 is a constant. Then p must be a factor of a sub 0, which is the constant, and q must be a factor of a sub n, which is the leading coefficient, by the way. In other words, in order to find the potential rational zeros of a polynomial, we're going to do this. We're going to divide the factors of a sub 0 over the factors of a sub n. So why are we doing this again? We're going to start factoring polynomials with degree greater than 2. It would be 3, 4, or 5 or more. So first thing that we're going to do is we're going to find the potential rational zeros by dividing factors of the constant by factors of the leading coefficient. All right, so we're going to try an exercise right now. It says finding the real zeros of a polynomial function. It says find all real zeros of each polynomial function. Use the zeros to the 2, should be to factor f over the real numbers, okay? All right. So this is what we're gonna do first. Excuse me. The goal here is to factor this function here, you guys. Notice x cubed plus 3x squared minus 5x minus 6. So that's the goal. Ready? And first thing that we're going to do is we're going to use the theorem, the rational zeros theorem to find the potential rational zeros. Okay, let's do that first. That's I'm going to write the steps here. Step number 1, find the potential rational zeros. All right. And how do we going to do that? Well, we're going to divide the factors of the constant. All right. What is the constant here? The constant is -6, right? Let's find the factors of -6. Well, factor of -6 is going to be plus minus 1 and plus minus 6. And what else? Plus minus 2 and plus
Plus
minus
minus
3, right?
Is it plus minus 1 or no?
Yes, plus minus 1,
So
plus
they're all
minus
plus
2.
minus.
Yes. Why is that? Because -1 times -6 is positive 6, right?
Yeah.
That's why they're negative. Thank you. Good question. And we're going to divide it by the factors of the leading coefficient. What is the leading coefficient? Equals to
1.
right, everybody? 1, the leading coefficient. So that would be plus minus 1. Is that clear so far? So if we divide the factors in the numerator by plus minus 1, we're left with plus minus 1, comma, plus minus 2, comma, plus minus 3, comma, plus minus 6. Already? Okay.
How come the first one doesn't cancel out?
No, remember, we are dividing. We're not canceling out. We are dividing. Notice, plus minus 1 divided by plus minus 1 is plus minus 1, right?
Yeah.
Yes?
Okay.
Yes.
Good question right there. Okay, so all these, you guys, are possible real zeros, possible. Now we're going to find the real zeros. We're going to factor f of x, by the way, okay? In order to find the real zeros, we're going to use synthetic division, and we're going to try all these numbers. Ready? All right. So step number 2. Find real zeros. Use synthetic division. All right. So let's start. Now let's start with positive 1. Okay. So synthetic division. Let's get the coefficients. 1, 2, -5, and -6. All right, so make sure in f of x you have all the degrees in descending order. We have x cubed, x squared, and x is the constant. So that would be 1, 2, -5, -6, right? And then here we're gonna start with positive 1, and let's do the synthetic division with positive 1. We're gonna do the same as we did before. Bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -5 plus 3 is -2. 1 times -2 is -2. -6 minus 2, notice, is -8. Notice the remainder is not 0, right?
Yes.
That 1 is not a factor. So now let's continue with -1 now. So we're going to continue with this potential rational zeros until we get a number that the remainder is going to be 0. All right? Okay, so keep going, you guys. Let me see here. Why didn't we use the 5? Well, you can start anywhere you want, you guys, okay?
I think -1 says 0.
Works? Okay, so let's try, seems that Cherry found 1, so let's try -1, okay?
Yeah, it's 0.
All right, pretty good. 1, 2, -5, -6, and -1, right? So let's bring down the 1 here. -1 times 1 is -1. 2 minus 1 is 1. -1 times 1 is -1. -1 plus -5 plus -1 is -6. -1 times -6 is +6. -6 plus 6. Now notice I have a 0 here. That means that the -1 is a real 0, you guys. Okay.
Can we stop there, or do we have to keep going with all the other numbers?
We can stop right here. Let me tell you how it looks here. We can continue here. We can do the other numbers here and find more. That would be one way to go here, you guys. Or let me tell you one more thing here, okay? let's continue this way. Notice, since we know that x equals to -1 is a real zero here, let's rewrite these numbers 1, 1, and -6 as a polynomial. I'll check the chat right now, okay, you guys? I'm gonna write this as a polynomial here, you guys, and I'm gonna do it right here. To write 1, 1, -6 as a polynomial, this one is x squared. We always write these numbers as a polynomial 1 degree less than the original leading degree of the original polynomial. If this is 3, then this would be x squared. Again, if this is x cubed, this would be x squared. So here, let me write this as a polynomial. This would be x squared plus x minus 6. Is that clear?
Yeah.
Everybody? All right. So now, notice what I'm going to do here. This negative
Wait,
1.
sorry. Teacher, can you explain that part for me again?
Sure, definitely. Notice. Again, this is what is left. I'm going to check the chat right now, you guys, okay? I'm left with 1, 1, and -6, right? I'm going to rewrite these values as a polynomial. In order to write these values as a polynomial, I'm going to check back the original polynomial that was given to me. Notice that this is x cubed, right?
Right.
So when I write the polynomial out of these numbers, I'm going to start with 1 degree less than the original polynomial.
Okay.
If this was 3, then it has to be 2 here. That would be x squared plus x minus 6. That's what I brought here.
Okay, so if the first number, let's say, was 2, then it would be 2 less than the polynomial.
No, it's always 1 less than this number here. Always 1 less.
Okay.
Always,
so if the number
all the
was
time.
2, it would be 2x squared.
If this number would be 4, this would be x cubed.
No, I'm talking about that number you're pointing at right now. If it was 2, it would
Oh,
be
that
2x
would be
squared.
2x squared. Yes, yes. You're right. Thank you.
Okay.
This number has to be 2. That would be 2x squared. You're right. Okay. Notice.
Professor, I have a question.
Yes. Uh-huh.
Okay, we have, is it 2 factors, x squared plus x minus 6 times x plus 1 right now, or no?
Well, we're gonna get there. Okay. You might be a little bit ahead of us. Okay.
Okay.
Okay. I'm gonna get there. Okay. Notice that -1 is a factor of the polynomial, right? Yes. Okay. So this -1 is the same as, let me continue here. I'm gonna write here x equals to -1, right? Yes. That's a factor of this polynomial, right? Correct. If I want to write x equals to -1 as a factor, that would be x plus 1. Is that clear, you guys?
Yes. I think I mean, for me, it's a little bit confusing.
All right, let me go back a little bit here. Notice, we found that x equals to -1 is a factor of f of x, right?
Yeah.
That's what I'm doing right here. X equals to -1, right?
Yes.
If I move the -1 to the left, I have x plus 1, right?
Yeah.
Yes?
Yeah.
Okay. Now, notice what I'm going to do. I'm going to rewrite f of x equals to x plus 1 times x squared plus x minus 6. See what I did? Now, I'm writing this f of x with these two factors, x plus 1, which comes from this -1, and the x squared plus x minus 6, which are these values, these values that we got here, right? Is that clear? If I multiply these two factors, I should get these values right here. But remember, the goal is to factor everything, right? So now, let's factor this trinomial. Let's factor x squared plus x minus 6. Let's use big X here. All right, I'm gonna check the chats here. I got some chats here, okay? All right, thank you, you guys. Some of you are ahead of us. Very good, you guys, thank you. So if we use long division, not long division,
It's x
big
plus
X.
3 and x minus 2.
Yeah.
Perfect, very good, very good. So let's write down, let's
I just
write,
guess it. I don't use the big X. I just
well,
guess.
use your own method. That's okay with me, okay? Use your
Okay.
own method, no problem. So here now I have x plus 1 times x minus 2 times x plus 3. So notice these are the factors, right? Yes?
Yeah.
The question would be factor f of x. This would be the solution, but notice.
Would you have to rewrite it from like say x minus 2 would go first, then it would be x plus 1, and then it'd be x
It
plus
doesn't
3.
matter. The order doesn't matter, you guys. It
Okay.
could be any order. It could be
All
any
right.
order. All right? Cherry, everything okay?
Yeah, like
All right.
no,
Alrighty.
like just the first part, like I know how you did the factoring and everything,
Mhm.
but I'm just like a little bit like still confused on how like the x plus 1, the second step.
Oh, right here?
Yeah.
All right. So let me do it right here, okay? Let me do it right here.
Because I know the x equals the -1. That was the factor. I know where you got that, but then how you get the x plus 1?
All right. Let me do this, okay? Let's say that I have the x plus 1 and I equate it to 0. And if I solve for x right here, what will be the answer?
Oh, -1.
All right. Then basically here I'm going backwards. I'm going from here to here. That's how I got the x plus 1.
Okay.
Make sense?
Makes sense. Yeah, it makes sense.
All right. So now let's find the solution. Now we're finding the real zeros here. We want to find the real zeros. In order to find the real zeros, make f of x equals to 0 and solve. Okay? Make f of x equals to 0 and solve. If we make f of x equals to 0 and we solve, you guys, what will be the solutions here? X equals to what? -1, right? X equals to what? 2. And x equals to what? -3. Is that clear? Does it make sense what we did?
Yeah.
Mhm.
Yes? All
so
right.
when it's f of x equals to 0, and we basically substitute the x's with the zeros.
Yeah, basically what we do here, and I'm going to do it right here. So basically this is what we're doing. X plus 1 times x minus 2 times x plus 3 equals to 0. And from here we say, you know what, x plus 1 equals to 0, or x minus 2 equals to 0, or x plus 3 equals to 0. I'm running out of paper here,
Right.
you guys. And then we solve for x. And that's how we got these solutions.
Thank you.
All ready? Good question. All right, so that would be the solution. Notice how we're using synthetic division to factor polynomials, then degree more than 3, right? Okay, so let me see if, all right, so it seems that we're fine. Let's continue with that. All right, so right here. All right, so there is one more here. I'm gonna leave this for you to do that a little bit later on your own, you guys, but we're gonna solve now this polynomial here. Now, notice that polynomial is x to the 4 minus x cubed plus 2x squared minus 4x minus 8 equals to 0. We're gonna solve it, and we're gonna use the same steps as we did before. I'm gonna focus that one right here. That's a little bit out of. Oops. Let me see.
You had it.
All right, right there. We're gonna
There you
solve
go.
that. So we're gonna do the same as we did before. We're gonna find the potential zeros, and then we're gonna use synthetic division to solve it. Okay, so let's do it. Let's find the potential zeros. Potential real zeros. And
Rational or real? Because last time you said rational.
rational. You're right, rational. Change to rational, please. Excuse me, potential rational zeros. Remember, are the factors of -8. What is the factors of -8? Plus minus 1, plus minus 8. What else?
Plus minus 2, plus minus 4, plus minus 8.
All right. Oops, excuse me. Divided by the leading coefficient would be plus minus 1. Let me focus right here. So the potential rational.
So the constant would be the numerator, and then the
constant would be the numerator, and the leading coefficient would be the denominator. All right. Okay, so the potential rational zero will be plus minus 1, comma, plus minus 2, comma, plus minus 4, comma, and plus minus 8. And then we're gonna do the same as we did before. We're gonna use synthetic division to check which one is now a real zero. So step number 2, find the real zeros by using synthetic division. So let's do what we did before. So again, let's start with 1 and I usually start with 1 and -1, you guys. So you can start with any of them. I usually like to follow an order. And let's start with 1. Let's see if 1 is one of them. All right. So this is 1, -1, 2, -4, -8, right? Those are the coefficients of that equation, correct? So let's start with 1. Let's see if 1 works. 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 is 0. 2 plus 0 is 2. 1 times 2 is 2. -4 plus 2 is -2. 1 times -2 is -2. And this is -10. Notice, does not work for 1. All right. So let's try the other ones. Let's see. Let's try the other one. Let's see. I'm gonna try -1 now.
Yeah, -1 works.
Oh, perfect. Thank you. Very nice.
Quick question. Why did you put 1 there 2 times?
The 1, 2 times. I'm sorry.
You put, because for other problems, we just put like each number once. That one you put 1 and -1.
1 and -1 here? This 1
yeah,
and -1?
How come you put it?
Because remember, these are the coefficients of the polynomial. Here is +1, and this is -1.
Oh, so now we have to do both of them.
Yeah, you have to write all the coefficients of this polynomial. 1, -1,
Okay.
2, -4, -8. That's the numbers that go right here. Make sense, Sherry?
Okay, yeah.
All righty.
Okay.
Pretty good. Very good. All right. So let's try -1 really quick. -1 times 1 is -1. -1 minus 1 is -2. -1 times -2 is +2. 2 plus 2 is 4. -1 times 4 is negative 4. Negative 4 minus 4 is negative 8. Negative 1 times negative 8 is positive 8. Negative 8 plus 8 is 0. All right, that means that negative 1 is a real 0, you guys. Is that clear? All right, so we're going to do the same as we did before, you guys. And notice what we're left here. Let's write the polynomial that we're left with. So since we started with 4 here, if we write the polynomial right here, that would be what? X cubed.
Cubed minus 2x squared plus 4x minus 8.
Perfect, minus 8. Now what we want to do is we want to factor this this polynomial right here. Okay, and we're going to continue now, but with this polynomial, we're going to be using a synthetic division, but now with this polynomial now. Okay, so here, what I would do is (1, negative 2, 4, negative 8). Here, you guys can start with 1 and negative 1 again. It might be possible. Or you can continue with the plus minus 2 is your option here. Okay. So I'm going to continue with positive 2. Let's see if positive 2 is one of them. Bring down the 1. 2 times 1 is 2. Negative 1 plus 2 is 0. 2 times 0 is 0. Bring down the 4. 2 times 4 is 8. Negative 8 plus 8 is 0. Notice, we're lucky. The 2 is also a factor. Everybody notice that?
Mm-hmm.
So now we got two real zeros, the negative 1 and positive 2. And notice what is left here, okay? I'm going to write the polynomial that is left here. The polynomial, and I'm going to write it right here. What would be the polynomial that is left here? So notice that we started with x cubed, right? This would be what? X squared plus 4. Is that clear?
Mm-hmm.
X squared plus 4. All right? Now, let me put it together now, you guys. Let me put it together now. All right. So this is what we have so far. X equals to negative 1. If I write it as a factor, that would be x plus 1, right? And now I have x equals to 2. If I write it as a factor, that would be x minus 2. Is that clear? And now, this is what we have left. Notice also that we have x squared plus 4. Let me put it together. X plus 1 times x minus 2 times x squared plus 4 equals to 0. Let me focus this thing right here. Is that clear how we got to that equation?
Mm-hmm.
All right. Now,
can you simplify?
Yes.
X squared minus or
Yeah,
plus 4?
yes. We're gonna remember here. We're solving. We're finding the values of x, right? So
Yeah.
next step is x plus 1 equals to 0, or x minus 2 equals to 0, or x squared plus 4 equals to 0. So what would be the solutions here? Well, here this is x equals to negative 1. That would be one solution. Or x equals to 2 would be another one. Or the other one, notice, let's solve this one here. X squared plus 4 equals to 0. And that would be x squared equals to negative 4. We're going to use the square root property here to solve for x squared here. So remember, x is equals to what? Plus minus the square root of -4. What is the square root of -4, you guys?
It's 2i.
2i. Yes, this is imaginary numbers. Remember that? Imaginary numbers
It means
now.
that we have-
Would it be plus minus 2i or would it
Yes,
just be 2i?
you're right. Plus minus 2i.
it means that only we have two solutions, x equal to -1 and x equal to 2.
Yeah, we have two real number solutions and two imaginary solutions.
Okay.
Okay. So that would be the answer. Is that clear, you guys? Is that clear? The process that it takes in order to solve or to factor polynomials, then degree more than 2, you guys. These are the steps. Ready? Any questions, you guys? All right. So let's move on. We're done with 5.6. Let's start 5.7 and let's see how far we go in 5.7. All right. 5.7 is a continuation from 5.6. And notice it says complex zeros, fundamental theorem of algebra. The objectives: find a polynomial function with the specified zeros. Find the complex zeros of a polynomial function. All right. Okay. Let's review what a complex number is. What is a complex number? Well, a complex number is a number of the form a plus bi, where a and b are real numbers, by the way, but a is the real part of the complex number and bi is the imaginary part of the complex number, by the way. Okay. So what is a complex number? By the way, all integers are complex numbers. I could have a plus 0i, and a is a integer. So all integers are complex numbers. All real numbers are complex numbers. So let me write something here. For example, let me write something here. Example of complex numbers. I can write 5 plus 0i. That's a complex number, but notice the 5 is an integer. The 5 is a real number, okay? I can write b as 2i. Imaginary numbers are complex numbers, by the way. Or I can write 5 plus 2i. So with this in mind, you guys, whatever all these numbers that we covered before, all of them are complex numbers. Real numbers are complex numbers, natural numbers are complex numbers, integers are complex numbers, whole numbers are complex numbers. So everything else that we cover are complex numbers, by the way. All right? Now, let's read this theorem here. Fundamental theorem of algebra. It says, every complex polynomial function of f of degree n greater than 1 has at least one complex zero. So the polynomials that we solved in the last section, you guys, are complex polynomials, by the way. The solutions that we found in the last sections are complex number solutions, by the way. Okay, now let's read this conjugate pairs theorem. It says, suppose f is a polynomial function whose coefficients are real numbers. It says if r is one of the factors. If r is equals to a plus bi, think of R as X. If one of the solutions of the polynomial is equals to A plus BI is a 0 of F, the complex conjugate R naught is equals to A minus BI is also a 0 of F. All right, let me explain this in other words. If a polynomial has a complex factor, it also has the conjugate of the complex factor. Let's say if I have A plus BI, that polynomial also has A minus BI. It always has the pair, the two of them, all the time. All right? So let's try an exercise and clarify that. It says, find a polynomial function having the given degree and zeros. Notice, the degree is going to be 4, and the zeros are going to be 3 plus 2i, and 4 multiplicity 2. Notice, let me concentrate here, 3 plus 2i. If this is one of the zeros that this polynomial has, it also has the conjugate of this complex. It also has the 3 minus 2i. Alrighty? Okay, let me do it this way. It's gonna be degree of 4, right? So these are the zeros, right? Let me write the zeros here. These are the zeros that we have, zeros right here. We have x equals to 3 plus 2i. Is that clear? But we said that if they have a complex 0, it also has the conjugate of this complex 0. So what is the conjugate of 3 plus 2i? That would be 3 minus 2i.
Minus 2.
So that would be x equals to 3 minus 2i. All right? But notice,
How did you get the minus?
because of the conjugate pair theorems that we covered. Here it says that if you have a complex 0, you also have the conjugate of that.
Okay.
So the conjugate will be negative. So every time that a complex 0 is given to you, you already know that you also have the conjugate. Let me focus here real quick. Okay, let's see. All right, I don't know. Technology sometimes is not perfect, you guys. Okay, something is going on here. All right. Sometimes we gotta be patient here, you guys. All right, the other I'm gonna write the other 0 is 4, right? I'm gonna, that would be x equals to 4. All right, so let me try to.
Professor,
Yes.
can you just zooming? I don't see. Yeah, please.
Yeah, right there. Oh, no.
Yeah, okay, let me try it again.
My thing is so glitchy. Like my Zoom has been laggy. I don't know if anyone else is having that problem.
Yeah.
Like it's all like glitched out.
The Zoom?
Yeah, I don't know if it's my connection or like just
no,
like
it's
maybe.
everybody.
You know,
Okay.
let me sometimes when I get rid of have more stuff here, the Zoom does not work. Let me just leave it by itself, because seems that when it is getting more than one piece of paper. Uh-oh.
Try to just move it up.
All right, perfect. Thank you, guys. All right, so the other 0 was 4, right?
Yeah.
So notice that if I now write it as a factor, let me write it as a factor. Now, as a factor, that would be, let me do it this way. That would be x minus 3 plus 2i. As a factor, that would be x minus 3 minus 2i. And notice the 4 has multiplicity 2, right? If I write x equals to 4 as a factor, that would be x minus 4 squared, right? Why the square? Because that's multiplicity 2. Is that clear so far? All right, so now this is what we have, you guys. This is how—
Wait, I don't understand. Why is it x minus 4 squared?
the square, because it says multiplicity 2.
Oh, okay.
That's why we're taking care of the multiplicity 2 with the square. Now, f of x, you guys, f of x is equals to a times x minus 3 plus 2i times x minus 3 minus 2i times x minus 4 squared.
I have a quick question.
Yes.
So you see how 4, would you use the conjugate and do -4 or no?
No, only for complex.
Okay.
What do we do with the degree 4 now?
Well, we're gonna get the degree 4 when we use FOIL to multiply all these factors. Okay. Notice that we have a here, you guys. Here we're gonna choose a ourselves. So we're gonna make a equals to 1, okay? We're gonna make our life easier for us. So I'm gonna write make a equals to 1. And now we're gonna multiply, we're gonna start by multiplying these two factors right here, these two factors, okay? We're gonna multiply these two factors. I'm gonna multiply those two first, okay? And hope not to confuse you here. I'm gonna do it right here. I'm gonna multiply these two factors right here, okay? So notice these two factors, notice how I'm gonna rewrite these two factors. I'm just gonna multiply these two, okay? Here. Notice what I'm gonna do. I'm gonna do it this way. X minus 3 plus 2i times x minus 3 minus 2i. All right, so notice what I did from here to here. I got rid of this parenthesis here and I grouped the x minus 3, plus 2i. And I did the same here. I got rid of this parenthesis right here. I grouped the x minus 3 right here minus 2i. Is that clear?
Yes.
Why did I do that? Because we're gonna use a formula that we already know. Remember that when we multiply the sum and difference of two binomials, let me write this formula that we're gonna use right now here, okay? I'm gonna write it right here. We're gonna use this formula. A plus b times a minus b equals to a squared minus b squared. Remember that formula? We're gonna use that formula. We can use FOIL, but if we use this formula, this would be much easier. Notice, this is the same, using this formula, this a squared minus b squared. This is a and this is b. That would be x minus 3 squared minus 2i squared by using this formula. Now we're going to square this binomial. What is x minus 3 squared? Well, that is the square of the first minus 2 times the first time the second, that would be negative 6x plus the square of the second, which is 9. Okay, minus, we're gonna square 2i squared. What is 2i squared? 2 squared is 4. I'm gonna read it this way, 4. What is I squared? But what is I squared equals to? I squared is equals to negative 1, you guys. I squared is equals to negative 1. We're gonna substitute this negative 1 instead of the I squared here. All right, so this equals to x squared minus 6x plus 9 minus, notice, that's 4 times negative 1 inside. Let me continue here. What is inside this square bracket, that's 4 times negative 1 is negative 4. This negative 4 with this negative becomes positive, right? So I'm gonna continue here. That would be x squared minus 6x plus 9 plus 4, correct? And if we put it together now, that would be x squared minus 6x plus 4 plus 9 plus 4 would be 13.
What happened to the x minus 4 squared and then the 1 on the outside?
Or x minus 4 squared. Oh, we're gonna put it together. Here, what I did, I just multiplied these two right here.
Oh, okay.
These two is what we got right here. Now let me put it together. If we make a equals to 0 now, f of x is equals to x squared minus 6x plus 13 times x minus 4 squared. Is that clear? Next, we're gonna square this binomial, x minus 4 squared.
It's minus 6x, right?
Yes, it is minus 6x, yes. So let me write here, x squared minus 6x plus 13. Now the square of x minus 4 squared, that would be x squared minus 8x plus 16. We're almost there, Cherry. We're almost there, okay? And everybody.
I'm just like, I just feel like you lost me at like the whole thing you did at the top. Like I barely understand.
Okay, so let me finish this problem, and if you guys want to wait a little bit more, I can go over again, okay? So let's finish this problem now. Let's spoil all this, okay? So f of x is equals to, what is x squared times x squared? X to the 4. What is x squared times negative 8x? That would be negative 8x cubed. What is x squared times 16? That would be plus 16x squared. And now I'm gonna multiply negative 6x times x squared. That would be negative 6x cubed. Negative times a negative becomes positive. What is 6 times 8? 48x squared. And what is 6 times 16? 6 times 6 is 36. We carry, that would be negative 96x. And then plus 13x squared. What is 13 times 8? That's negative 8 times 4 is
58 or something.
104.
How much?
Negative 104. 13 times 8. That's 104x. And what is 13 times 16?
Someone said 208.
208. All right. Now we're gonna combine like terms, you guys. Well, x4 is by itself. We have negative x cubed, negative 6x cubed. Negative 8 minus 6 would be what? Negative 14x cubed. Now the x squared. What is 16 plus 48 plus 13? 16 plus 48 plus 13. That will be 77
Yeah.
x squared. Now what is left here? What is negative 46, negative 96 minus 104? I think that would be 200 minus 200x plus 206.
208? I thought it was 208.
208. 13 times 16 is 208.
Yeah.
Yes, 208. Yeah, let me change this. Thank you, you guys. 208 plus 208. So this would be the solution. That would be the polynomial degree 4. Notice the degree 4 is right here. Cherry and everybody. That would be the solution.
So we solve, and then that's the degree we're supposed to get.
Yes, because this is what we're looking, right? We're looking for a polynomial that's going to be degree 4 with these zeros. And when we do all this work, we get to the solution, which is right here. Okay. So 9:33. Thank you, you guys, for waiting. For the ones who are waiting, I'm going to go over. You guys want to wait again? I'm going to go over all this work that I did here. Okay. And this is just multiplying these two, okay? I'm gonna go over again. For the ones who wanna wait, please wait. If not, have a good day. All right.
You know, teacher, I just have one question. Like, what did you write? Like, I think the third row, x squared minus 6x plus 9 minus bracket 4, and then what's in the bracket?
Let me write it again. Let me do it all together. Sounds good? I
Okay.
think that probably more than one of you guys have the same question. So let's give it a try. I'm just gonna concentrate on that multiplication by itself. Okay, let me get this together here. Let me rewrite it here, okay? I'm gonna write, I'll fix it right now, okay? Let me write, this is how we started. X minus 3.
It's blurry.
Yes, I'm gonna fix it right now. Let me just write this right there.
Okay.
X minus 3 plus 2y. Okay. So that's what I'm gonna do. This is what we had first. And notice what I'm gonna do next. Now I'm gonna group the x. I'm gonna get rid of this parenthesis, and now I'm gonna group the x minus 3. Notice this is next. X minus 3 plus 2i. I'm gonna do the same on the right side. X minus 3, I'm gonna group the x minus 3. Oh, excuse me, this should be minus here, okay? Minus 2i. This is positive and this is negative. Is that clear so far what I did there?
Yes.
And then from here, I'm gonna use a formula that we are familiar with that goes this way. A plus B times A minus B is equals to A squared minus B squared. Notice that if we look back here, this looks similar to this formula, right? This is A plus B times A minus B, all right? So I'm just going to check really quick on the chats here. All right, thank you, you guys. All right. So Yeah, we finished 2 sections, so I'm probably going to assign homework for 2 sections. We're not done with the last section. Thank you, John and Roger. Okay, so let me continue here, you guys. Exactly what I did here, right? Since that's clear what I did here. Now, using this formula, when we multiply the sum and difference of 2 binomials, we get a squared minus b squared, right? What is a? A for us now is x minus 3. And what is b is 2i. Using this formula, now what I have is x minus 3 squared minus 2i squared. Is that clear for everyone?
Yeah.
All right. And then we're going to do what we did. We're going to square this binomial. Remember, the square of the first minus 2 times the first times the second. 2 times 3 is 6 minus 6x plus the square of the second, which is the square of 3 is 9. All right? Minus 2i squared. But remember that I is equals to square root of -1, but I squared is equals to -1. So here is 2 squared is 4i squared. But I squared happens to be -1. I'm going to substitute the I squared by -1 here, right? So now what we have is x squared minus 6x plus 9 minus 4 times -1. And what we have is x squared minus 6x plus 9 minus -4. And now we have x squared minus 6x plus 9 plus 4. And last, we have x squared minus 6x plus 13. Excuse me. So this is what we got when we multiply these two factors. We have complex numbers right here. And this is the trick that we use from here to here in order to use this shortcut, you guys. Okay. And I know it's a little bit confusing at first, but as soon as you learn this trick from here to here and you use these formulas here, it's not difficult, you guys. Okay. And after we substitute that, let me go back to the problem that we did. Notice what we did is this part right here, which I wrote it here, you guys, times x minus 4 squared, which comes from here, which is this value, by the way. I bring it down. I square this binomial, which is here. And then I use FOIL. I FOIL these two trinomials, which is all this expression. We simplify, we reduce, and we get to what we're looking for. All right. So it would be a good idea, you guys, to try B on your own. Okay. And see what you guys get. You guys can try it right now. We can try it together. You guys try it, and we can do it together. If you still have time, I mean, I don't mind.
Professor, can you put the other paper once? I want to take a picture of that.
Sure.
Please.
And this is gonna be online, right? You're gonna upload it online?
Yes. Definitely. Okay. So my recommendation, you guys, practice. I would try B. For example, let's start B. Some of you still here. Let's say that we want to try B. Then you can finish this a little bit later. Notice B is degree 5 now. Okay.
It's always going to be the same way, right? It's
Always.
going to be the same as
every time it's going to be the same. Notice. Let's start by writing the zeros. Okay. So the zeros is going to be 2, right? So this is x equals to 2. And another 0 is going to be negative I. Notice this is a complex now, negative I. So if x is equals to negative I, it has to have the conjugate. So what is the conjugate of negative I? Is positive I. Is that clear? So
since x equals negative I is a complex number, that's why it has to have a conjugate. If it's complex, then it has to have a conjugate. But
yes.
if it's just an integer, like a normal number,
Yes.
then it doesn't.
You're right.
Okay.
Yes. So here, the conjugate of negative I should be I. That's the conjugate. Is that clear? And notice we have another one, which is 1 plus I. So we have x equals to 1 plus I.
And then 1 minus I.
You're right. So the other one would be 1 minus I. All right. Now, if you guys write it now as factors, here would be x minus 2. Here would be x plus I. Here would be x minus I. Here would be x minus 1 plus I. And here would be x minus 1 minus I, you guys.
Wait, it's x plus I for the negative I?
Yes, when you rewrite it, that becomes, remember that you're moving the 2 to the left. When you're moving the 2 to the left, becomes x minus 2. When you move the negative I to the left, becomes x plus I. If you move the I to the left, becomes x minus I.
Okay.
All right? Okay, so you guys, f of x would be the multiplications of all these factors now. F of x, I would say choose a equals to 1. And now f of x is equals to x minus 2 times x plus I times x minus I times x minus 1 plus I times x minus 1 minus I. That would be, and then you guys have to multiply all these factors. So remember what we did when we multiply, start by multiplying these two, use this formula, do what we did before. Is that clear?
Yeah, so now it's x minus 1. You put the bracket
Yes,
on.
yes. Okay. And here, you guys, since you have x plus I, x minus I, use the same formula that we used before. Here, you're gonna use this formula twice. A plus b times a minus b equals to a squared minus b squared. You guys gonna be using this formula twice for this one, for these two, and for these two. But for these two, just use the formula the way it is. Here would be x squared minus I squared. Is that clear for these two? But for these two, you guys gonna do what we did before. So here, let's do one more step here. F of x is equals to x minus 2. If you multiply x plus I times x minus I, you guys, use this formula right here. That would be a squared minus b squared. That would be x squared minus I squared. But what is I squared?
1.
Negative 1, right? Remember, I squared is equals to negative 1.
Always?
All the time. All the time. If you substitute I squared by negative 1, it becomes x squared plus 1. Is that clear?
Yes.
Yes? Okay. Then you guys are gonna multiply these two as we did before.
Just move the parenthesis sign.
Yes, move the parenthesis sign and use this formula and do all that simplifying, you know, and then just put it together right here, and at the end you're gonna be multiplying all whatever you get here with this and with this.
I kind of get it now.
Okay, so here would be f of x. Let me just do one more step. Here would be x squared minus -1. And here is f of x equals to x squared times x squared plus 1. But remember here, is that clear so far?
Mhm.
So all you gotta do is multiply these two here and put it right here and continue right here. Is that clear?
Can we do that together?
I'm gonna let you do it, you guys, because I want you to practice. I can do it together. We can do it together, but I want you to practice. So you guys gonna do the same as we did 1 minute ago. So I really want you to try it, and we can check later on. You can send me an email, and I can even check it with you guys. But I can do it myself, but I want you to try it on your own. Is that clear, you guys? Sounds good?
Yep.
Alrighty, so we're gonna stop here, you guys, unless you guys have more questions, okay? But I'm going to assign homework. And let's see if I'm gonna assign a quiz, or I'm gonna let you know what's coming, okay? And I'm gonna be grading your quiz and this weekend, and I'm gonna be posting your grade, okay? So an exam
Is I squared always, you said
negative
negative
one.
one?
All the time, you guys. -1 all the time. Okay?
Professor,
Yes.
are we gonna have extra credit?
Yes. I'm gonna assign also extra credit.
Okay,
Definitely.
thank you.
Yes, definitely. Okay, for everybody. So we're almost done, and most likely an exam is coming really soon. Okay, we have a spring break next week, but dude, go over your homework, go over and practice, you guys. Okay.
Professor,
Right.
I have a question.
Yes, Mohammed. Go ahead.
Regards of my quiz number 1, do I email you or I can question right here?
I'm sorry, again, repeat what you said.
I had a question regards of my quiz number 1. Do I ask here or I email you?
You can ask me right here, no problem, if you don't mind everybody listening. Yes.
Yeah, the grade with my paper and on the canvas was different.
Okay, so can you you can take a picture and make a PDF and just email it to me, and I can recheck your grade, Mohammed. Is that okay?
I already did it. I'm just
Okay,
waiting
so
for
no
you.
problem. So I'll check on that. I haven't done anything so far, you guys, but
Okay.
starting tomorrow, I'm gonna go over all your grade, all your papers, you guys, all your quizzes and all the corrections that I had to do on my own. Okay, you guys. So
Okay, thank you so
I'll
much.
catch up with you guys grading all your paper this weekend. Okay, because
Okay,
seems that I'm not gonna go out this weekend, you guys, as you do. So don't go out, you guys. Stay home, be safe. Okay.
Okay.
Invite your friends over and do homework together.
What if my friends have the virus?
No, don't invite them. Don't just talk to them on the phone. Okay. Alrighty, you guys. So have fun, you guys, and be safe. Okay.
All right,
Okay,
thank you,
All right.
Professor.
All right. Take care. Bye bye, you guys.
Bye.
Oh, John already got the answer, by the way. John, good job, John. Thank you. Already.
All right. Thank you, Professor. Later.
Already. Later. Bye bye.